Hello YouTube and welcome back to the series about creating modular monolith in .NET 5 and the C# 9. Sorry for the huge gap between those episodes. We both had some, I would say, side activities. So this is why we had to postpone the recording of this series, but hopefully within next weeks we will be on the track again and we'll deliver each new episode every hopefully weekend or maybe each 2 weekends. So hopefully you will regret us this I would say summer break. Today's episode will be slightly different because I will be recording only by myself. And the explanation is that, we had some difficulties when it comes to technicality of recording. Actually, we covered today's topic on the live on stream, but for some reason the stream was not saved. So we decided to record this once again offline. We did it a couple days ago together with Peter, and it turned out that the OBS was playing some tricks on us, and the video quality was just unacceptable for us. You barely could see the code. So this is why I'm recording all by myself today, but of course this will change in the future. We'll get back to our full DevMentors squad together with the Peter. So that's, I think, enough for the introduction, and we can get back to the code. Just to briefly remind you, we've ended up with the situation in which we actually published the integration events, which we covered in the previous episode, from our application service in the conference module. So as you can see, we have this very simple, I would say, domain/application service, which is responsible for taking the DTO about some sort of conference, creating the entity, persisting this into the repository, and after we actually, let's say, commit the transaction, we want to publish the integration event, which might be useful for some other modules, eventually maybe microservices that could react to this particular information. So we, at the very, very end of the previous episode, we introduced this layer of abstraction, additional layer of abstraction called iMessage broker. The reason is that we don't want explicitly to inject into our application services the component, directly the component that will be responsible for publishing our integration events. Whether this happens in memory when it comes to modular monolith, or whether we'll actually decide later to distribute our system, we want to avoid the situation in which our application service is aware of the fact that we are using, let's say, in-memory event dispatcher, or maybe RabbitMQ client or the Kafka client or whatever we're going to use. So just to avoid this abstraction link, we introduce this message broker, which I think that in the next few episodes will actually pay off, because this layer of abstraction, of course, will help us with the testing, but also gives us this opportunity to switch the implementation depending on our needs. And of course, the implementation within this service will remain the same thanks to this additional iMessage broker abstraction. So if we will get back to implementation, as you can see, for now, we have just throwing an exception, not implemented exception, and our today's job will be to actually implement this. And we mentioned in the previous episode that, the very obvious step for us will be doing something like this. So doing just private read-only, and then I-event, let's say, dispatcher, and we could make the usage of this, right? And somewhere in the publish async, we'll just call our dispatcher. So we'll do something like dispatcher.publish async, pass the messages, and that will be pretty much it. Since we already have event dispatcher being implemented, and this is the dispatcher purpose is to look up for the event handlers and basically call the handle async method. So this looks like a natural move. However, we also mentioned that we will introduce slightly, I would say, different strategy when it comes to storing our integration events. Because typically, if you have the modular monolith implementations, you'll probably see that they are all built on top of the concept of shared contracts. So let's say that I have this integration that needs to be made between our conference module and, just to remind you, the tickets module, which subscribe to our integration event and based on this perform some sort of business logic, which for now is just printing this information. So typically what you would see in the implementations is like the conference module will introduce another class library, which would be called some sort of, modules, conferences, shared or common or contracts. And this will contain the definition of our integration event. And basically what we would do is taking the reference directly from the tickets core to our shared exposed assembly. And yeah, we'll basically take the reference and use this type in here or in this generic parameter, right? So this is normally how you would approach this asynchronous integration. And what it gives you is that since both conferences and the tickets modules basically work on the same type, this sort of simple integration built on top of event dispatcher is now possible, because now if I want to publish my integration event, let's say from the conferences module, the event dispatcher will basically look for all the registered event handlers and basically call this handle async method without any issue. Now, what we would like to have and what we actually started in the previous episode is slightly different approach, which is inspired by the microservices. So something more typical in the microservices world, in which each module will have its local definition for this contract. So if you would see, both in the conferences and the tickets module will have the same definition for the same integration event. So in here, I have the events and I have the integration event, which is declared as a record with 3 parameters. So I have 3 properties actually. So we have like identifier name and the participants limit, and this is declared as an integration event. Now within my tickets module, I have exactly same record, which is, as you might see, looking at the namespace, completely different implementation. So from the runtime perspective, even though the payload and the definition and even the name is exactly the same, those are 2 different types. So it's not like it won't be possible to basically try to take the object of this type from the conference module and safely call this function from the tickets module, because on the runtime I will have some sort of type mismatch exception probably. So this is not that easy with the approach in which we have the local contracts instead of shared contracts. So what we would like to do is to basically perform some sort of translation between those types. Thanks to this, we'll be able to safely call this function, even though that will publish on the, let's say, producer side, will publish the object of one type, will then somewhere in the middle translate this to the, let's say, destination type, and at the third step we'll call this handle async method safely. So this is what we would like to do. And of course, in order to do that, we will need to introduce more components which will be responsible for that translation and basically for this, let's say, communication between the modules. And yeah, I think that this is the first step in this episode. So within our shared abstractions, I will introduce another directory. So I will just call this modules, because that will be more or less related to, modules stuff. So within this modules, I will introduce new interface, and I will call this IModuleClient. And basically the purpose of this client will be, as the name partially says, this will be more or less some sort of equivalent of, let's say, HTTP client, but for the communication between the modules. So whether you will have the direct communication or asynchronous integration, this, assuming that we are still within our modular monolith and everything happens within, in memory, we'll use this client for the whole communication or the integration. So I'll create the module client interface within our abstractions, and for now, I will just create one method declaration, which will be responsible for publishing stuff, and will cover the direct communication in one of the next episodes. So this will be basically asynchronous method as you might expect. So non-generic task, and method will be called publish async. So publish async. And in here, I will for now just leave this as an object when it comes to the parameter. Of course, some of you might be wondering whether we shouldn't we use our iMessage marker interface. We could, and probably at some stage we'll change this to iMessage. For now, I'm just not quite sure whether this will be an issue if we will already narrow this down to messages. I think that this should work just fine, but let's just leave it in more, I would say, generic way. So, of course, this is just the simple interface. Of course, we need the corresponding implementation. So I'll just create within our shared infrastructure, I will just create another directory. I will also call this modules. So within our modules, let me just create the class called ModuleClient. All right. And of course, I will just, for now, leave it as internal sealed. And we'll just implement our IModuleClient. All right. Now, the question is, how will I actually perform this whole translation? Because now, if we think about this, let's say I have our handler, right? So our conference created handler will accept this integration event of, I would say, the local equivalent. So now when we publish let's say on the producer side, on the producer side, we need to translate this, and this whole client needs to know to which type we need to translate between we actually call this handle async, right? And of course, the obvious choice is to build some sort of simple registry in which we could store this information. So we could basically using name of the particular integration event, look in the registry, and just keep this information to which type you would like to translate and call this handle async method. So this is exactly what we would like to do right now. We'll just build this very simple in-memory registry, which will be giving us this information. And for this particular reason, I will just, within these modules, I will create few more classes and interfaces. So I will call this simply iModule registry. Of course, this could be something more precise, like iModule types registry or whatever, but I think that this name is just fine. Now, within this registry, I would like to have two methods. One will be for adding something to registry, and the other one, as you might expect, is getting something from registry based on, let's say, the key. And before we do this, we need to create the type in which we would like to put and get from our registry. So I will create another class. I will call this basically module broadcast registration. And the broadcast, the name is just, I think that's spot on. I mean, if you think that it could be something more, I would say that fits better. Of course, this could be, the broadcast is basically, means that we'll publish this message to 0 to n subscribers. So I think that for now, the name is just right. So the idea about this is that we'll keep the mentioned type. So thanks to this, we'll know to which type we would like to translate our integration event. So let's just call this receiver type, or maybe the target type. Target type could be also something like this. Of course, we would like to also keep the information about the method that we would like to eventually call. So we'll just put the function, which will accept an object, and will return the task. So in most cases, this will be nothing more but the function that will be our event handler or command handler, maybe, if we'll decide to publish the command instead of integration event, which will be rather likely. But yeah, let's just call this handle. And our key, which will be string. and our key, which will be nothing more but the target type dot name. So just the name of the type. So the convention here is that the key will be nothing more but the name of the type that we'll publish. So let's say for the conference created, the key will be conference created string. So I think that this is it for now. And of course, within our registration, we need the constructor, which is now added, and we can get back to our registry. So as I mentioned, we need two methods. First one will be adding the registration. So I will just create the method void add broadcast registration, which will accept module broadcast registration. And the second thing will be maybe IEnumerable of this module broadcast registration. I will just call this get broadcast. Let me just type it, because as you already see, I'm very likely to make a lot of typos, which if you watch the distributed.NET core, you probably know that I'm quite known for this. Yeah, so we have the registry. Now we'll just create the drive type. Of course, we need to implement this one. So I will just implement the missing types. Let me just put it into separated class. Yep. And yeah, I think that we can already implement this as internal sealed. Now, this whole registry, as I mentioned, will be nothing more but some sort of very simple in-memory registry. So I don't see any point of creating more robust implementation that would persist this somewhere. So everything will be built on top of the regular list. So I will just do private read only and then list of this module broadcast registration. So broadcast registrations, and I will just do new. Okay. And now we can just implement those two methods. So getting will be nothing more but doing broadcast registrations dot where, and of course we follow x dot key equals key. So that's pretty much it. When it comes to adding stuff, of course we can check a few things. Let's say we can check whether registration is null. If it is, then we can maybe throw new maybe invalid operation exception or something else. So let me just do this. Invalid operation exception, empty broadcast registration. What we can also check is see whether our registration does not contain the type which was made in the runtime. So the dynamic type, which actually doesn't exist within our code, just to make sure that this doesn't actually happen. So registration dot target type dot namespace is actually in here, because if this is the dynamic type, this will be actually rather null. So if this happens, I would also like to make sure that I will not support this sort of type publishing, because it will be just impossible to create the event handler for something that doesn't exist rather than in the runtime. So invalid operation exception, and I will just type missing, let's say target type namespace. All right. And of course, if everything is fine, I will just add this to my list, right? So registration, and that should be it. Of course, at this point, I think it could be maybe a good idea to introduce also an extensions. So the extension, as you probably guess, will be responsible for for the whole registration when it comes to this modules directory. So I will do public static and then I service collection add modules. Let me just do a slightly different thing. Okay. So add modules, maybe module quests. All right. And in here, I will of course pass our iService collection services. All right, return services. Okay, and already I think I can add our module client, and we'll just for now register the client as a singleton. So IModuleClient, and the actual implementation will be in here. And of course, at some point, during the bootstrap, it would be cool to basically seed our registry. Of course, this is rather the technical decision whether we would like to expose some sort of API which allow the developers to register manually, to add this to something to our registry manually using this API, or the approach that I think me and Peter like more is basically would like to create some sort of, maybe not a beautiful code using the reflection, which will basically during the bootstrapping of our application basically will scan the whole assemblies and register this automatically. So just once we add, let's say, new integration event and the corresponding event handler in the different module, we just don't need to do anything more than this. We don't need to explicitly add this registration somewhere in our code base. So this is rather the matter of preference, so whether you would like to make this explicit or implicit. Both have let's say pros and cons, so it's rather up to you. So for now I will just do public maybe void, I think would be cool. So static void, and I will call this add module registry, and this will also have the service collection as the parameter. So yeah, our registry, maybe let me just do one more thing to call this already. All right, so let me just implement this for now. And as I mentioned, the whole idea is, yeah, it won't be the very beautiful code, but hopefully you will get the whole idea. So what we would like to do is, once we'll actually start our application, we'd like to take every single integration event that we have defined within our code, no matter whether this lies in this module or on this module or in this module. For every single one, we would like to create this registration, which will contain the type itself, and we'll already, as a function, will pass the function which will call our event dispatcher. So event dispatcher will be put into our handle. The target type will be nothing more but the type itself, and the key will be built automatically using the integration event name. So you can already see that we are now doing some sort of convention over configuration. So the convention is, to make this whole thing work, we need to be sure that both on the, let's say, publisher and the subscriber side, we need to keep the same name when it comes to integration event. So something that you probably already do when it comes to microservices, because you need some sort of convention to make this work, right? If I publish the, let's say, conference created on my conferences module, I need somehow to know that this needs to be translated to the conference created module on the tickets side. So this is how this will actually work. So let's start with first defining the list of integration event within our whole application. So the assemblies will be app domain dot current domain, and then get assemblies. And of course, this will give us, I would say, more than enough when it comes to assemblies, because not only the assemblies within our application, but also some third-party assemblies that comes from, let's say, some libraries. So of course we could narrow this down using word statement, but let's just keep it simple for now and eventually optimize this at some point. So we have the assemblies, and now we need our event types. So event types will be the assemblies, then select many, X, and then get types. This will flatten this to one collection, and then where, in which X is class, and type of iEvent is assignable from X. All right, and let's say to array. All right, so we have our event types, as you can see. This is the array with the types, and now it's just a matter of creating the whole registration in the container for our module registry. So I will do the following: services dot add singleton, and I would like to register iModule registry, and I will use the overload, which gives me service provider. So at first I would like to create a registry, of course. So registry equals new module registry. Then I would like to get our event dispatcher. So event dispatcher equals sp.getRequired service iEvent dispatcher. Okay. Yeah, and then comes the, I would say, the part in which we need to enumerate through the type and add this to our registry. So I'll do the for each, and I will for each through the event types. I'll call this event type. Okay. And first thing, I would like to get the target type. So the target type will be the event type, just to match the parameters in our registry. It will be much easier to analyze this, let's say, for other developers. Then our handle. So the handle will be the function that will need to accept an object and needs to return the task, right? So if you get back to our definition and our registration, we need to provide this function. Now, of course, I cannot leave this as a just var, and the issue is that if we put the lambda expression in here, the lambda expression itself doesn't have a type because it's homoiconic, right? I can assign multiple lambdas into different, let's say, functions or expressions, just because the lambda itself, needs some sort of context to determine the type. So if I will do something like event and then something like task.completed task, even though it looks like a valid expression, if you would see, is implicitly typed local variable, right? So we have an issue because this could be, actually assigned to multiple types of functions. So of course we need to specify that this will be actually the function that accepts an object and will return the task. So now everything is just fine, but this of course doesn't make much sense. So we need to actually, instead of this task completed task, do some sort of magic. And this magic will be, as I mentioned, based on the reflection actually. So this will do, this will take us a few lines of code. So I will do event dispatcher.getType. This will gives me, of course, the type of the dispatcher, and I will call the method get method. And I will pass the name of and iEvent dispatcher.publish async. Okay. And now once I have the method, I would like to make this generic. So I need to put into this generic argument, I would like to pass the object of type. And of course, this is something without reflection that is simply illegal. So I cannot do something like, let's say, dispatcher.publish async and inside it put event type, right? This is something which is illegal in the C#. And to put this artificially, we need to make the usage of the reflection. So Once I have the method, I will just call make generic method. And in this generic parameter, I will put our type. So event type. And now I can call invoke. And I want to call this on the particular object. So the object will be our event dispatcher, and our only parameter, as you can see, the publish async accepts only one parameter. I will just pass our event. So I will do new because this needs to be an array since this is generic API, and I will just pass the event that comes from our handle. The reason that this is not building right now is that invoke, as you can see, returns the object, and of course we expect the task, so we need to cast this explicitly to task, and now this handle is I would say correct by the definition. And now we can do the registration. Will be nothing more but doing a new module broadcast registration, passing our target type and our handle. And finally we can do something like registry dot add broadcast registration registry, and at the very end, after the loop, we just return the registry. All right, so hopefully the whole idea is more or less known. Of course, we could make this as a local function. This will be more sufficient because the function itself will create, of course, the dedicated class, while the local function will actually make the method within the same class. So, of course, speaking of the performance, it's much better to add this as a local function. Of course, we can do this and maybe put this at the very end somewhere in here. So thanks to this, we will actually gain some performance. Even though the whole registry will keep the function that is built on top of Clojure, because as you can see, the handle function that we put into the registry actually make the usage of the dispatcher in here. So this actually will create a Clojure and will hoist this to heap, but you know, this is how it is, and for now we just want to make this whole thing work. And I wouldn't say this is the most performant code that you would see today. But yeah, I think that at some point we'll just revisit this and think about some possible optimizations. One thing though is I need to, of course, call this add module request somewhere. So let me just do the following. I will just do services dot and then add module request, just not to forget about this. And I will just want to make sure that maybe we'll do something like this, just to make sure that we'll go through every single module before we call this, so our scanning will actually work. And yeah, I think that when it comes to registry, we are pretty much done. Now, of course, we need to make the usage of this, right, somewhere. So the client will be an obvious choice. I will inject this IModule registry into our client. Damn you, typos, jeez. Okay, so I have my module registry, and yeah, now let's just think about the whole process that we need to perform in order to make this publish async work. So first thing is that, of course, once we accept some sort of message, we would like to look into the registry for some registrations, right? Then, assuming that we have some, we would like to loop through each of them and perform the conversion to which type? The type that is given inside each of the registration. And then once we'll actually have it, the assumption is that we can safely call this handle function, which underneath will be, as you see, calling our dispatcher, and dispatcher will look through the actual event handlers that will be called. So this is the whole idea. I don't think it's very sophisticated, but for now should work just fine. So let me just implement this quickly. The key will be, as mentioned, message.getType and name. Now the registration. So registration, maybe registrations, plural, because we might expect more than one. Of course, if there will be a situation in which, let's say I publish the conference created integration event, and let's say both tickets and speakers would like to react to this somehow, then I will be in a situation in which there will be more than one registration. So I will do module registry, then get broadcast registrations, and of course passing the key. Now, once I have it, I could do the for each loop. So the for each loop will go through the registrations. So registration, and let me do the following. First, I will just assign the handle, just to make this more pretty. So the handle, and then I need to perform the whole translation. Now the translation, I think that it would be cool to extract this basically to the static method. So I'll just do public static and then an object and translate type. Okay, and I will accept two. Maybe object will be better. So object and the type, I will accept two parameters. Or maybe I'll call this target type, just to keep the convention. And yeah, the whole idea about the translating, because now I'm in the situation in which I have an object of one type and I would like to change this to another. And yeah, there are different ways to actually tackle this this issue. The simplest one though is the one that I'm going to implement, and this will be based on the serialization. So the whole idea is that, you know, of course the assumption is that not only the name is, let's say, the same, but also the payload needs to match at some point, right? So just like with the REST API, if the, let's say, Angular app wants to call our post endpoint, we basically expect some sort of shape of the message, right? So let's say that I have my controller, host controller, and I have post. So I'm saying that I do expect that this post will be called with the message in the body will have this structure, will have, let's say, property description, right? Of course, this is just a matter of the, let's say, security, whether the invalid payload will be passed along to the controller or maybe it will be cut off before. But at this stage, we are just assuming that, yeah, once someone wants to translate one type to another, we probably would like to, basically leave it to the serializer and see whether the serializer itself can handle this or not. Of course, if there will be some issue, we'll probably get the exception from the serializer directly. Of course, if you want, you can wrap it into some sort of try-catch and throw your own custom exception. But for now, we'll just leave it to the serializer. So the idea is very simple. I will just do JSON serializer from the system text JSON. So serializer.serialize, and I will just pass the object. Of course, this will give me the string. Now I'd like to deserialize the string to our target type. So I will just wrap it into another JSON serializer, deserialize, passing the string, and the second argument will be the target type, and this is job done. So very simple assumption, quite similar to what you typically do with your client-server communication. You just have this, let's say, agreement. You have the expectations put explicitly in your controller, and if someone is basically sending a, let's say, correct payload, then it gets deserialized and the proper action in the MVC controller is being called. If there's some issue with the, let's say, this serialization, deserialization, you probably will get an exception, and the same thing will happen in here. Of course, if you would like to make this more performant, maybe directly try to, translate the type in the runtime. It's just a matter of the translation. I think that this one is the easiest way to do this, to achieve this. For most developers, this will be obvious choice to actually follow and to overcome this issue. So our translated message will be nothing more but the result of this translate type, in which we pass the message and the target type from the registration. And now, since we already know that this is translated type, we can safely call our handle, passing the translated type. Sorry, translated message. And of course, to make this more performant, now I can do the following. So var tasks equals new list of task. And instead of awaiting this multiple times, I will just do tasks.add and then handle like this. And at the end, I will do await task when all. When it comes to integration events, I would say that the order, the order in this case will not be crucial for us. Of course, if it is, for some reason, of course, there might be the situation in which you maybe would like to favor the approach, let's say, that gives you, let's say, the Kafka with the guaranteed order, then yeah, maybe this implementation should be also changed to the sequential rather than doing task when all. But yeah, for now, let's just assume that this will be task when all. And yeah, probably, as I mentioned, maybe we'll revisit this whole code and try to make this more performant. If you have any suggestions also, please comment down below. I would really appreciate this, and I'm pretty sure that Peter would appreciate this as well. So we have our module client implemented. So we are getting closer into the final solution, because now our module client can be used in our in-memory message broker. So we'll not use mention dispatcher, because that makes not sense in our approach with the local contracts. But instead, we'll do the following. So we'll use IModuleClient. So module client will be injected into our broker, and yeah, now we can implement our publish async. So few maybe null checks before. So first, I would like to make sure that the whole collection is not null. So if this is null, then I don't think that actually there is a need to throw an exception. Maybe just, let's say, I would like to silently abandon this job. Then I could check whether there are some messages which are basically null. So the collection is not null, but the message inside is. So I would like to make sure that this actually will not be processed further. So X is not null. Just remind you, feature from C# 9. In the C# 8, you had to do is and then curly brackets. That was the equivalent. Now, finally, we have something that is, I think, more clear and then understandable for everyone. So we have the messages that are not null, and now we can actually call our module client and publish the messages. So it will be await.module client publish async, and of course I need to pass one message. So I'll do the following: var tasks equals messages dot select x goes to module client publish async x, and then await tasks dot when all tasks. And yeah, that's pretty much it. So once we actually have it, maybe in here I will also do one more thing. So I'll just check messages any, just in case. Not to call this, but yeah, even if this will be empty, we'll just not call this anyway. So yeah, this is just, I would say, checking. Okay. So assuming that everything is set up, and I'm pretty sure it is, because on the conferences service, we have the publishing already. Of course, thanks to our abstraction, we didn't have to change the implementation at all. So this remains the same. We have the publish, which publishes the conference created integration event. This underneath will make the usage of our newly created module client, which underneath should translate the message and basically call eventually our event handler that lays onto the tickets module. So yeah, let's just put a few breakpoints. So in here, of course, in the not the controller itself, but maybe in here, also in the client itself. So somewhere here, yeah, and here. Okay. Yeah, and maybe one more in here. So we could see that this module registry is actually being created at the beginning. Okay. All right. So let me just run this, and we should see immediately what actually is happening. So build succeeded, which is kind of surprising, but yeah. Event types, let's see, we have two types. Maybe I will just put in here. So we have conference created on the conferences and tickets module. So everything seems to be just fine. Of course, the question though is, all right, but we are registering not only the invoke for the conference created on the ticket side, but also for the conferences module. And of course, in the conferences module, there is no event handler for this message because we are the producer. We are not subscribing to this. So will it break the code itself? And the answer is, of course, no, because if we would go to our event dispatcher, you could see that, yeah, basically we would look for the handlers. And apparently, if there will be no handlers, this select will produce, no tasks and will basically proceed further with no exceptions. So yeah, we'll just artificially, let's say, register the conference created on the conferences side, even though there is no handler. But yeah, apparently if there will be some need, probably kind of rare, but the need for publishing the integration event and subscribing this in the same module, this will be also supported, right? For now, this just will add one more registration, which is, let's say, will be not used. Of course, if you would like to filter this, there is no issue. You could try to check whether each of the integration event that you would like to register also has the corresponding event handler. If not, then you would like to skip this type. But for now, I would just leave it as it is. So let me just proceed. This should rather be working. And I will go to Visual Studio Code. So let me just create a post for the hosts. At first, this should give me new host, and I will just put it in here. And yeah, once I have the host, I can create the conference. So send the request. I can see that I have the modular, in my modular monolith, I have the invocation of my conference service. So this conference created integration event is happening. Now I'm in my publish async because I use the module client through in-memory message broker. So in here, I make the usage of my module client. Now the client will perform a few steps. So first, look at the registrations. And as you might expect, we have two registrations because we actually got the conference created from the tickets module, which we are currently interested in, and we also have the self-reference to the type that we're actually publishing, which isn't dangerous as we already discussed. So we are now going to enumerate through those registrations, and hopefully at some point, we hit our event handler using our event dispatcher. So we have the await task window. Of course, now we reached this because we ended up with all tasks that we had, all two tasks, which were nothing more but calling our event dispatcher and calling our event handlers. And now everything ended up with 201 on for the client. So we can see 201, the conference has been created, and we are pretty much good to go. So to sum up, we added I would say, quite important stuff into our modular monolith, because now our modules are still highly decoupled. They are not aware about the fact that other modules actually exist, because there is no shared part between them containing the shared contracts. Every module keeps the local contract for its own, and everything, I would say, looks quite similar to what you typically see within the microservices, which is great because you can already, even in the, let's say, in the monolith environment, you can already learn these ethos. And once you actually decide to distribute your application, you would already know the, I would say, the pain in some sort of, at some point, the pain with that the local contracts actually produces. Because now, if you think about this, of course, this will work just fine. But yeah, at some point, it would be cool to keep some sort of testing on the consistency of those local contracts. Because with the shared contracts, the situation is quite clear, right? I have one definition, so if I will change something with this definition and I have multiple references to this, the code probably, assuming that I have breaking change, this will probably break the code in multiple places. While at this approach, let's say that I have my conference created on the conferences, but on the tickets side, I will decide for some bizarre reason to, change the name to, let's say, conference name, right? So as you can see, this actually, of course, this is just a perfect code for our tickets module. But of course, once I would actually publish our integration event with this property, and I have inconsistency in the property's name, once I would actually deserialize this on the, let's say, consumer side, this property would be null, right? Because I have the inconsistency when it comes to the payload. So yeah, to keep track of this, it would be cool to introduce some sort of consumer contract driven testing. And this is why I said that this also, it's not like the perfect solution, because this already gives you some, I would say, more work. This is the pain that I was saying. But the bright side of this is that you already know this difficulties when it comes to the consistency of the contracts. So once you will actually decide to distribute your application, you'll be already prepared for this, right? You already know the way this works and how to overcome the issue with the contracts consistency. More, I would say, cool things about this approach is that once you actually decide to split this into microservices, there's less code that needs to be, I would say, rewritten, because assuming that you would have shared contracts, so I would say that the classic approach, once you actually put this into separated repository and you would like to make this a separated application, of course, you can no longer use the shared assembly. So you need to rewrite this and put this as a local contracts into your microservice. While in this approach, you already have this from the day zero being put into your module. So you just need to, put this into your own Kestrel instance, put this into separated repository, but there is no need to rewrite the contract definition in something else. And you already, even though at the beginning this might be a little bit harder to follow and to test this contracts when it comes to consistency, once you actually migrate to microservices, you'll already be more experienced than someone who has followed the typical approach of doing this. But I'm not saying that this is better. This is just I would say, some sort of an alternative approach. I personally really like it because of the mentioned reasons, with the learning the ethos when it comes to working with this type of code. But of course, there are also a lot of people who use the shared contracts, and that is just fine. So I'm not favoring this approach over another. I'm just trying to show you something cool, and hopefully you will also learn something about the way that you could create your own modular monolith. So I think that this will be it when it comes to this particular episode. Of course, now this whole mechanism of publishing the integration events isn't perfect because it's working though, but I would say it isn't perfect. And the reason is that maybe I will just show you what I mean is that if we would come back to our application/domain service in here, I will do the following. I put another breakpoint just after the message broker.publish async, and let me just create another conference. So I don't remember the logic though. So maybe I'll create another host. That's embarrassing that I don't remember the code that we've created 3 months ago, and this is yeah. So I have the publish async. Yeah, let me just go through. So we have the publish async, blah blah blah, and we hit our event handler, right? So we have the some sort of application logic that is happening in the different module. And once we actually finish it, and we have this task when all being completed, we later come back to this particular place. So we have the logger.log information, and yeah, we display some sort of text on the console. Now the issue is that if you have an experience with the let's say microservices, you probably know that typically once I actually publish the message, the publisher has no information, no clue about the subscribers and their work, right? So I'm just publishing the message, and in most cases immediately I can process further with the method, while in here, because everything is built on top of async await, of course this is non-blocking operation from the IO perspective, right? It's not like thread sleep or the synchronous equivalent. So from the IO, this is non-blocking operation. However, from the flow, the whole data processing perspective, this is the blocking operation, because the message broker needs to wait until every single subscriber finish their work. Then the task when all actually ends up, and the await operator allows us to proceed further, right? And then I can finally display the information about the conference that has been created. So this is something that typically you would like to avoid. Of course, it depends on the scenarios, but typically you would like to have the situation in which I publish the message and I immediately can process further, and somewhere maybe on the thread pool, on the background job, I would like to eventually process with all subscribers that has some sort of job to do with the integration event that they received. So in the next episode, we'll change the implementation of our message broker and we'll introduce slightly, I would say, more robust, I think that's safe to say, more robust approach, which will allows us to create this, let's say, fully asynchronous from the protocol's perspective solution, which will behave more like the, let's say, RabbitMQ or some other, Kafka or other brokers that you probably know. So thanks to this, there will be no I would say weird behaviors when it comes to producer side, which needs to, for some bizarre reason, wait for the completion of each of the individual subscribers. So hopefully you enjoyed this. Sorry once again for the huge delay, actually break, and hopefully we'll manage with Peter to make it more consistent when it comes to releasing the materials. One thing though is that we are not quite sure whether we will do this via the streams, or maybe we'll get back to, let's say, offline recording. There are a few reasons. I think that with the streams, it's quite hard for us to make the streams work, because there needs to be perfect I would say conditions for both of us to record, and for let's say that for some period now it's been more, I would say, chaotic. Peter now got a second dog, which is very active, so it could be quite hard to record the streams every single week. So I think that will be much easier for us, and way easier for for the whole schedule to record this offline and leave the streams for now off. We'll see also, maybe this will change in the future, but yeah, this is how it is, and hopefully you will still get the materials in I would say more consistent schedule. So this is all for now. We'll probably see you in the next episode next week about this asynchronous publishing. Hopefully you will enjoy this, and yeah, see you next time.